Okay, I've got a two-pipe assembly shown like this. Aluminum pipe, steel pipe, bunch of stuff given on there. And I put 12 kips, or 12,000 pounds, right at the center there. Okay? And I want to find, what do I want to find? I want to find the stresses in each section of the pipe. So I'm going to start with statics, as I do most problems. And I've got basically this guy that looks like this, right? And again, I've got P pushing down just like that. Basically, then I'm going to have A pulling up like that, and probably B pushing up down at the bottom like that. And then statics will tell me that A plus B, those are the ones going up, have to equal P, right? And P is 12,000. So again, that's going to be A plus B equals 12,000. So there is my statics equation. The problem is it's one equation, two unknowns. So I need another equation to help solve this. That's again where this compatibility equation comes in. Okay, and what I know is that the total deflection between A and B, delta AB, has to be 0, right? Because I've got rigid wall or floor and ceiling there, so there can be no elongation of the total thing. Now, likely, AC is going to increase, but it's going to increase the same amount as BC is going to decrease. Okay, so essentially, I add the two deflections together, right? Where likely this is going to be an elongation AC that's probably going to stretch out as I look at the picture. And what I'm going to do is I'm going to add to that the compression of BC, right? So essentially, the elongation of A is going to equal the contraction of B. Okay. So, of course, we know that delta equals PL over EA, right? So I'm going to do that for each one of these guys, okay? So I'm going to say, okay, 0 equals, I'll do AC first. Now, I got to find the force going through each member here. Well, that one's not too tough. I make cuts here and here, and you can see A is going through the top piece, B is going through the bottom piece. If I cut that and separate them out, right? So I've got A going through the top, B going through the bottom. Okay. So again, now looking at A's in tension, based on the assumption that I've got there. So it's going to be positive. Okay. E is given. The top one is steel, so that's going to be 29 times 10 to the 6th. Okay. A of this guy is given in the problem. It's 1.03. Okay. And then on the top one, I have A and then L. It doesn't actually give me the length, but we're not going to need it, and I'll show you why in just a second. Okay. To that, I'm going to add the elongation or the contraction. It's going to be a negative, and we'll talk about that in a second, of what's going through the aluminum pipe on the bottom, which again, the force through that is B, and that's actually negative B because B is being compressed, right? Okay. So again, doing the bottom one, this one is aluminum, so it is 10 times 10 to the 6th times its area, which is 8.92, again given in the problem statement. Here's where the negative sign comes in. Because B is in compression, as I have it drawn there, it's going to be a negative sign. This guy is going to be contracting, okay? And its length is 2L. Okay, and this is where the L's are going to cancel out because, I just divide through by L and it goes away here. Okay, so that is my second equation. Okay, and it relates A to B. And again, it's basically just saying that AC elongates the same amount as BC contracts. Okay, going through the math, okay, simplifying this down, I actually find that A equals 0.6697B. And it's basically, that's just algebra that I skipped over, solving A in terms of B with all this. Again, L is going to go away. I can divide that through, and it's just figuring out what A is relative to B. So now I've got this equation, and I've got this equation. Now I have two equations, two unknowns. Okay, so all I need to do now is say, okay, well, 12,000 equals A plus B again, but A is 0.6697 B plus B, right? From that, I can find that B then equals 7187, and I can find then that A equals 4813. So it's just two equations, two unknowns, okay? And again, I use statics first, then I use what I know about the deflections to get my second equation. After that, it's just algebra. Now I have the force going through the steel pipe, I have the force going through the aluminum pipe, and I can very easily say, okay, well, the stress in the steel then is going to be the 4813, okay, where that's the force going through AC there, and divide that by its area, which is 1.03. Oops. 1.003. Okay. And then that equals 4.67 KSI. Do the same thing with the aluminum. Okay. Negative again because it's in compression. Okay. I know I found it to be a positive, but remember that that was under the assumption that it was negative. So the positive answer when you make means your assumption was correct. Divided by 8.92, and that equals negative 806 psi. And again, negative just means that it's compression. Positive means that it's in tension.